Hello and good evening, everyone. And I think today I'm gonna show you some interesting stuff, like for the part of the KMP. And yeah, it's still within the KMP, but this topic today will be like a little bit like a more general to software engineering instead of like the KMP like technology, right? So today I'm gonna show you some one of those design patterns which called state machine. If I open my timer app, it's a timer app built by KMP, right? It's a desktop. So we start from here. As you can see, right? And if we tap here, it will start a timer, right? And this timer, they got a reminder, and it's got a final alarm. So it means like two alarms actually can work in. And then this alarm got a few state, right? It can you click can toggle it as a mute or like a normal alarm bell, right? And also like one of another feature in this is you can like in the fly change this. For example, you can change this to 0 to 1 to 2. Even now, when you like actually your timer passed and some points of this reminder, you can still like decrease or increase the number to make the alarm like re-enable or like disable it. So it looks like a very simple app, right? But it's still some complexity to deal with. So, but how do we deal with this complexity? This is what I'm going to show you today. So, if you ever familiar with design patterns, for example, if you search design patterns on Google, you get a list of them, right? And for example, you just click the first of them, and the pattern I'm going to show you today is called the state pattern. So yeah, if you want more detail about like deep into the what the state pattern, what the state machine is, like you can like do your own study and research. But today I'm gonna show you is like how to build a state machine for our timer app, right? And I think the state machine, one of the benefits is you can manage those states, manage the timer, the alarm, like whatever the state it could be, very clearly and simple. So you don't need to worry about like it's gonna confusions or like unexpected complexity you couldn't deal with, right? So this can make this problem really simple by using the state machine. And so I got a whiteboard here. I'm gonna draw something. And for example, let's think of like our state machine, right? Our state machine got a few states. We can maybe draw a state here. I can draw a state here, and like it's called inactive, right? Inactive. It's the first time using this. Gonna be tricky. Inactive, right? Inactive means this timer is not triggered at all, right? It's dormant. Or we say like in this case, it could be, for example, the time has passed, right? In this case, it will be inactive. It won't be alarmed again. And another state, and which is very important, is active, right? Active, we define this active state means like is waiting for being alarmed, right? For example, the alarm is in 1 or 2 minutes, and it's just waiting for the time come up and alarm the sound. And another state, because we got like a looping, right? Looping in the compose page. So every second we check like if it's past the time. So we get a status to make it easier. It's called alarming. Let's say alarming. Alarming means like we are currently like the time is just past the threshold, and we are raising the like whatever the notification or the alarm sound, etc. So this is like ongoing and like immediate state, right? And another one, what we defined will be helpful to us is we call it is post, right? We can also call it like say muted. Yeah, whatever. Like it means like in this state, one of the thing to remember is we still need to keep the time, right? We need to have a time here. So it means like whenever in the future, if the user unmuted, it should be directly go to the active and it still got the time. So in this case, we got the time as well, right? Because it's an active state, so we need to keep a time and let the system know when and to alarm the sound, right? So once we define the status and the rest of the things will be super simple, right? What we need to do the rest is fill the conditions of the transition of like what each state, right? For example, we can define inactive to active. So it means you can think of like when what happened, right? And this alarm could be transit from the state inactive to active. It could be like simply, for example, one is you set alarm, right? You set alarm and it will go to the active, right? Or you like you increase the timer, like for example, and the alarm has passed, right? It's a past 10, so you don't need to alarm it again. But if you change the timer and to future, and so it from inactive become active, right? This could be the state, and vice versa. Like in what condition it will go from active to inactive, right? For example, if you the alarm. And for example, you adjust the time to the past, so the alarm doesn't need to alarm anymore, right? Like, for example, the time and go down and go to the past, right? And for the active to alarming, that's obvious, right? It's just check the time, like if your time is just past the threshold. Right, that's the thing, and if the what makes this from alarming to inactive, right? So it's just like whatever it comes, like count next second, and it will go to there. So it's like no condition at all. It's anyway, it goes to inactive after alarming, right? And now we need to consider the pause, right? If we click the mute button. Right, click the mute button and it will go to pause state. And if it's unmute, right, it go to the active state. So yeah, this is kind of like the state machine or state pattern and we have defined. So in this case, yeah, let me see. It also will be some like edge cases, for example, if we get paused and if the time passes, can also go to inactive, right? Or you set a new timer, but it's still in the muted state and it will go there. So yeah, but anyway, like means like you can like with the least effort and of your logic thinking, you can like draw this state graph, and then you can clearly know like what you have missed, right? Then like you won't be cause any confusion, and you can have a great idea like in the code base what you need to write, right? Okay, now let's get back to the code. And as you can see here, we define alarm state here. Use a sealed class, and this will be the alarm state. And there are a few states we just defined in this whiteboard. See if I can make this smaller and yeah, see, yeah, it's yeah, we put it here and yeah, just make it as a reference, and you can see it here. No, sorry, let's just see. Make it here. Yeah, it's much better. Yeah. So you can see we got the four states we defined here: inactive, alarming, and active and paused. right? The rest is toString, etc. is full, and debugging purposes is easier if you printed them out. And notice here, it got a inactive and alarming. Actually, they are objects instead of data class, right? Because in these days they don't need to keep any data, right? But for active and post, we have a variable. It's called like alarm time. So it means like in this state, we can keep the alarm time here, so the system will know when to receive the alarm, right? And then based on that, and in the home screen, and it could be better, right? You can have a more structured, but just demonstrate how it works. And for example, this will be the simple handling of the state machine, right? It's have a one clause when the warning state is inactive, and it's got some condition, right? So if this condition is somewhat based on our state machine, and it goes to pause or either go to active. So it won't be do this over and over again. You can just review the code yourself, and just to tell you how the state machine works and help you simplify your logic easily, right? So yeah, this is today we're gonna have. Thanks for watching. Hope it's helpful. See you next time. Bye bye.